Hi, everybody. I told you I would make a video for today's lesson. And I'm seeing in here that a lot of the confusion was because I made some detailed mistakes. So I'll try to highlight those detailed mistakes that I made. If you, yeah. And I won't do every single problem in here, but I'll do enough that I hope you should be able to figure out the rest of them on your own. Okay. So the first one, there's a couple things. Number one, when you go to type in your numbers in this table, I didn't realize when I put in the units that the units would cover up your numbers. So that made the table really hard to use. I'm sorry for that. I've made a screenshot, so I'm just going to draw on the table. So that's my bad. And then the other thing that made things confusing is here in the table, it says rate in meters per second. But the question is, at what rate in meters per minute did each of them run? And so I know I was helping at least one group that was finding things in meters per second correctly. That was being marked as wrong because they didn't find it in meters per minute. And that's my bad. I was confusing. So this is how it would go. So Tyler, 30 minutes. 30 minutes. Ran 4,200 meters. And then meters per minute would be 4,200 divided by 30, which I believe I did on my calculator is 140 meters per minute. So the book was looking, or this activity was looking for the answer of 140 meters per minute. But if you took this 140 number, it's 140 meters in 1 minute, and you divided that down by 60 to get meters per second, you would have gotten 140 divided by 60, which is 2.33 meters per second. This also, I would consider that a correct answer because that is the same speed. It just has different units. Right. So then Kieran, half an hour is still 30 minutes, 6,300 meters. And then if I divide 6,300 meters divided by 30, I get 210 meters per minute. And if I divide that down by 60, I would get Kieran's rate. So this was Tyler. Kieran's rate in meters per second would be 3.5 meters per second. Meters per second. So if you got 3.5 meters per second for Kieran, that is also correct. And then I believe, actually goes at the same speed as Tyler. So goes 45 minutes and 6.3 kilometers, which is 6,300 meters. And then 6,000, I'm running out of space. 6,300 meters divided by 45. Again, I'm using my calculator. Is 140 meters per minute. So if you got going 2.33 meters per second, that also is correct. And you find these rates by dividing meters divided by minutes. Make sure everything's in meters, make sure everything's in minutes. There you go. All right. So it's the same data. And this question asks, how far did Mai run in her first 30 minutes on the treadmill? We can do this actually in two ways. I'll show you the way. I'll show you the way that we could do this if we didn't already have an answer from the previous slide. If you had an answer from the previous slide, you know that my runs 140 meters in 1 minute. So you could do 140 meters per 1 minute, but I want to take that up to 30 minutes. So if you already knew that, times 30 times 30, 4,200 meters in 30 minutes, which makes sense because it should be the same as Tyler. But if you didn't notice that, or if you did it a different way, or if you asked me in class, because I was looking at this problem independently of the other problems, so we've got minutes and kilometers. I would think about a double number line, kilometers and minutes. And I know 15, that's 0 and 0. 30, 45, 60, that goes on forever. Okay. I know that in 45 minutes, I ran 6.3 kilometers. And I want to know how many kilometers she ran in 30 minutes. So here to get from 45 down to 15, divide by 3. So to get from 6.3 down to this number, I'm going to divide by 3. Got space over here. 6.3 divided by 3 is 2. 6, subtract 0. So it's 2 wholes. Bring down that 3, 2.1. So then it'd be 4.2 kilometers in 30 minutes. And this wanted meters, so 4.2 kilometers, but they were asking for meters, so 4,200 meters, which is the same thing as we got doing it this way. Cool. All right. Next. Oh, this guy's bigger. Tyler and Kieran each started running at a constant speed at the same time. Tyler ran at a rate of 4,200 meters in 30 minutes, and Kieran ran at a rate of 6,300 meters in a half an hour. All right, so those are both 30 minutes. So 4,200, 6,300. How much time will it take for Kieran to have run 1 kilometer more than Tyler? 1 kilometer is the same thing as 1,000 meters. So we're looking for the difference to be 1,000 meters. So what's the difference now? The difference now is 6,300 minus 4,200, which is 2,100 meters. I'm going to do... I'm wondering if I want to go half and half and half and half, or I think what I'll do is I'll do 1 minute and then I'll scale up from there. And I have those answers from earlier. So I know that Tyler did 140 meters per minute and Kieran did 210 meters per minute. So I'm going to use those answers here. 140, and my brain lost the other one out of my brain. 210. Okay. So then that's a difference of 70 meters. And I want a difference of 1,000 meters. So here what I'm going to do, 70 times what number gives me 1,000? Oops, too far. 70 times what number gives me 1,000? That's the same thing as doing 1,000 divided by 70. I'm going to use my calculator. 14.285. So that's, my calculator tells me 14.2857. I'm going to go ahead. I want to round to the nearest tenth, I think. So I'm going to look at the hundredths value. 8 is close. 8 means I round up. So this is closer to 14.3 minutes, or 14.3. So times 14.3. So I multiply everything up by 14.3. So 14.3. 140 times 14.3. Oops. That's 2002. And then 210 times 14.3. And again, I'm doing this on a calculator. 3003. So it's actually 1001. You know what? That's close enough. Because I'm not going to, that's less than a centimeter off. I think that's fine. Cool. All right. That was tricky. Best deal on beans. Okay. So for the baked beans, the most expensive to the cheapest, let's go ahead and find the unit price for each one. And the unit price is going to be the cost, so dollars divided by cans. So unit price is how much dollar for one can. So 8 for $6. This is going to be $6 for 8 cans. Maybe I'll... Okay, so it's $6 for 8 cans. But I want to know how much for 1 can. So I need to divide both of those by 8. 6 divided by 8 is the same as 3 divided by 4, which is 75 cents. 10 cans for $10. This is $1 per can. 80 cents each. Well, that's 80 cents each. And then 2 for $3 is $1.50 per can. So we're trying to do most expensive to least expensive. So this is the most expensive. So it's $1.50. Then $1 per can is the second most expensive. And then 75 cents is cheaper than 80 cents. So this is the third one, and that's the fourth one. Okay. So my strategy there was that I found how much money for 1 can. Okay. And then this one, the price of the new can, this was tricky because you had to read really carefully. So all of these that we've already thought about are 15-ounce cans. The last store listed is also selling 28-ounce cans of baked beans for $1.40 each. So in order to compare the 28-ounce can to the other cans, we need to have it be the same number of ounces. So what I would do for this one is I would figure out how much it would cost for sorry, I can't write and talk at the same time. How much it would cost for 15 ounces at that price. So if it's $1.40 for 28 ounces, oops. I'm going to take that down to 1 ounce. So to do that, I divide by 20. Oops, what just happened? To do that, I divide by 28. So 1.4 divided by 28, that's 5 cents an ounce. And then 5 cents an ounce. I want to take that up to 15 ounces. So here, I need to multiply times 15 because 1 ounce times 15 gets me 15 ounces. Times 15. So 5 cents times 15 is 75 cents an ounce. 75 cents for 15 ounces. So the price of the new can is 75 cents for 15 ounces. So how does the new price compare to the other prices? 75 cents for 15 ounces. That is the same as it's the same as this one. That's 75 cents for one can, and one can was 15 ounces. So it's the same as the cheapest one. And I think that one was a little bit confusing. So, all right, there you go. Hope that helped.